Hello everyone, welcome back to course on cryptography and network security. In today's session, we are going to be discussing on the classical substitution techniques. In today's session, we'll be going discussing on introduction to classical cryptography, the concepts of substitution ciphers. So under the substitution ciphers, we will be discussing on Caesar cipher. So how the working principle of the Caesar cipher and an example of how to perform an encryption option. The second substitution technique we are going to discussing on Playfair cipher. So how to generate a key matrix. So what are the various rules are available for the performing the encryption with a step-by-step example. At last, we'll be going discussing on how the Caesar cipher and the Playfair cipher is going to be performed different. So at last, we will be going performing the conclusion. In today's session, my students will be gone able to learn understanding the concepts of substitution cipher in cryptography, and they will be able to explain the working of Caesar cipher encryption method, and also they will be able to apply the Caesar cipher with a given shift key, and understanding the Playfair cipher and its digraph encryption technique, constructing a 5x5 Playfair matrix using the keyword, and also performing the step-by-step encryption using the Playfair rules. So now we get into the introduction to substitution cipher. So basically the classical substitution techniques. So we call it as substitution cipher. It works by replacing each letter of plain text with another letter, and the replacement follows a specific rule or the key. It is one of the oldest methods used in cryptography. The main goal is to hide the original information of the message. So example includes Caesar cipher, Playfair, Vigener cipher, Hill cipher, one-time pad, like goes on. When we start with respect to the very first substitution technique called Caesar cipher, Caesar cipher is a simple substitution cipher. In this method, we will be gone considering the each letter given in the plain text is shifted by a fixed number of positions in the alphabet. The number of positions shifted we called as the key. So it was used by Julius Caesar for securing the communication. So that's why the name they have been kept as Caesar cipher. And we also call this as shift cipher. In the Caesar cipher, each letter in the plain text is shifted by fixed number of positions in the alphabet. So we are going to be use the encryption formula called C equals P plus K modulus 26. So where the P is going to be represent the position of the plain text letter, the key, the value which we are going to be shifting or replacing the position of the plain text letters, and the C is nothing but the ciphertext letter after performing the operation. Here we are going to be understanding by taking an example, the plain text hello. Here we have a 5 letters, so that the key which we are going to be using is 3. So every letter which is available in the given plain text is going to be get shifted by 3 positions. So in the very first thing, the alphabetical letters starts from A to Z will be go on give the positional numbers. So A is going to be takes as 0th position, B is going to be takes first, C second, and so on. When it reaches to the Z, the position number for Z will be 25. So now with respect to the plain text, what we are going to be converting from plain text to ciphertext, here hello, the positional values of each letter in the given plain text. For H, the positional value is 7, and for E it is 4, for L 11, 11, and for the O 14th position. Now the key value what we have been considered here is 3. So I'll just go on substituting below the each letter positional value with a key value. So as I shown in the previous case, the equation for encryption is C equals P plus K modulus of 26. Now I'll be gone performing 7 plus 3 10, 4 plus 3 7, 11 plus 3 14, 11 plus 3 14 and 14 plus 3 17. I just wanted to go on find out what the alphabetical letter is comes under in these positional values. So when I come with that, the cipher letters will be H is going to be replacing with K, E is going to be replacing with H, L is replacing with O, and L is going to be replacing with O, and at last O is going to be replacing with R. This is how we are going to be performing the encryption operation in the case of Caesar cipher. So this is the encryption goes on. Suppose when I'm going to be adding the value of plaintext positional value plus the key value, if it is comes greater than 26, so what we supposed to do in that case? So here we have taken the plaintext is X, Y, Z, and again the key value we are going to be considering is 3. So converting the letters into the positions, X value takes 23, Y value is going to be takes 24, and Z is going to be takes 25. When I perform the P plus K operation, 23 plus 3, 26, 24 plus 3, 27, 25 plus 3, 28. So in these conditions and all, we don't have any kind of letters which is going to become under these positions, that is 26, 27 and 28. Under these conditions, we have to be going to perform the modulus operation. See here, when I'm going to be performing the modulus operation, so 26 mod 26, the remainder is going to be gets as 0. 27 modulus 26, the remainder will become 1. And 28, when I'm going to be performing the modulus with 26, becomes 2. So now I will be go on finding out the values with these 0, 1, 2, 3, the position of the letters will become A, B, C. So that is nothing but the plain text X, Y, Z we have been taken, and the cipher text for each of those plain text will be A, B, C. So this is how we will be go on performing about the encryption. The same thing which we are going to become for the decryptions and all. Instead of P plus K, we are going to be performing C minus K. The cipher text character positional values is subtracting with the key value 3. So and we are going to be get back our plain text. So this is how it is going to be work in the case of Caesar cipher. So now we move on to the Playfair cipher. Playfair cipher is again a classical substitution cipher technique. It is going to be encrypting a pairs of letters that we called as a digraphs instead of a single letter. So in the previous Caesar cipher, we used to go on replacing the position of the letters by one. So here we need to be going consider a pairs of letters, also called as digraphs. It was invented by Charles Wheatstone and promoted by Lord Playfair. So because of that reason, they're going to be kept the name of the person who has been promoted by the Lord Playfair. So in this method, the cipher uses 5 cross 5 matrix of letters generated by using the keyword. So and also the letters I and J are treated as the same letter. It provides the better security than Caesar cipher because it encrypts 2 letters together. This is how we can able to say is better than Caesar cipher. So how we are going to be constructing the Playfair matrix? Choose a keyword. Example, monarchy is the keyword we are going to be taking, and these letters of the keyword, without repeating any letter, we have to be gone write it, filling the remaining spaces with the other letters of the alphabet. And again we need to be keep it in mind, we are going to be combining I and J into a single position in the matrix. So now we are going to be arranging the entire keyword and other alphabetical letters in the given 5 cross 5 matrix. So when I come with the very first row of the given 5 cross 5 matrix, so monarchy, I will be gone continuously writing whatever the key which we have been chosen. After that, see here, monarchy. So once all the characters of the given keyword is filled in the 5 cross 5 matrix, the rest of the cells will be go on filled with the other alphabeticals which is available. So that is B, D, E, F, G, and as we mentioned, I and J will be considered as one single letter. Then K, L, P, Q, S, T, U, V, W, X, Z. So this is how whatever may be the keyword we are going to be choosing to perform the encryption operations, we have to be go and construct a 5 cross 5 matrix. There are certain rules we need to be go and follow in the case of Playfair technique to get the cipher text from the given plain text. The very first rule, so if the characters, what the characters we are going to be taking as the letters and all, the pair of letters, both the letters, if it comes in the same row, then we have to go and replace each letter with a letter towards its right. Then the second one is, suppose if both the letters falls under the same column, then we are going to be replacing each letter with the letter below it. Suppose if the above first two rules are not satisfying, then we have to be go with respect to the third one, that is we called as rectangle rule. So replacing the letters with the letters in the same row but opposite corners. And if a pair contains repeated letters, so in the case of hello, HELL, so in this case we have to be go on insert one dummy letter that we call as an X in between the two repeated letters. And if the plain text has an odd number of letters, then we can able to add a dummy letter at the end of the letter, so in order to make it even. So these are the rules we have to be go on follow it. So when it comes to Playfair cipher, so encrypts 2 letters at a time. So here we are going to be taking an example to understand how a Playfair cipher is going to be working. So keyword monarchy and the plain text is instruments. So we know it how to construct the 5 cross 5 matrix for the monarchy. So I'll be go on writing the monarchy continuously in the given matrix. Then rest of the cells I'm going to be filling with the rest of the alphabets other than the alphabets which comes under the keyword. So once I construct the 5 cross 5 matrix, the next step will be we are going to be preparing the plain text. So entire plain text what we have been considered, that is instrument, I'll be going dividing into two letters. One is in, IN, ST, RU, ME, NT, and the last character is single. So in order to make it as an even, so I'll be gone making use of the last letter is a dummy letter, that is X. So we are adding X if needed to make pairs. Then we start applying the Playfair encryption rules. So first we have to be gone find out the very first pair, so whether it is going to be fall under the same row or not. See here how we are going to be replacing the letters. So here we just taken an example to understand how the same row elements will be get replaced with the other elements. So A, R. So in the given 5 cross 5 matrix, A and R, so both is going to be comes under the same row. So then I'll be go on replacing the A with immediate right letter, that is R, and the R value will be get immediately replaced with M. So this is how I'll be go on converting AR into RM. Next rule is I need to be go on check again the same letters, a pair of letters, whether it is falls under the same column or not. So again we are going to be taking an example to understand. MU, see here M and U both are comes under the same column, then immediately below those characters I'll be going replacing it. So for M I'll replace with C, and for U I'll be replacing with M. So the next one, so MU is going to be get converted into CM. So Suppose if the pair of letters is not comes under the same row or same column, then the third rule will be the rectangle rule. If letters form a rectangle, replace with letters in the same row but opposite corners. See here, I, N we have taken. So I is here and the N is in this position. If I take this whole, so it forms an rectangle. So I will be go over for replacing the letters, that is I is replacing with G and N is going to be replacing with A. So G and A will be the replacer letters of I and N. This is the third rule. So now whatever the plain text we have been considered to understand this Playfair cipher, that is instruments IN forms the rectangle. So I'll be going replacing with G, A. S, T is going to be comes under in the same row. So then I'll be go on, see here, S and T. So S is replaced with T and T is replaced with L. Then R, U, so rectangle, again MZ, ME, CL, NT, RQ and SX, TU. So this is how I'll be go for performing the encryption. So in the case of decryptions and all, so I'll be go for in reverse order. So in the case of IN, GA, if I take G and A, again G and A is going to be forming a rectangle. So opposite of those. So G will be I, A will be N. So I'll be going to get back my plain text by performing the reverse operation. So whatever the rules we have been learned to perform the encryption operation. So when it comes to the comparison, so how the Caesar cipher versus the Playfair is going to be working. So with respect to the features, the type, so it is a mono-alphabetic. Yes, we are going to be replacing a single letter with the other position. But when it comes to Playfair, it is going to be performing with a digraph or a pair of letters. And performs the encryption with one letter, and here it is a 2 letters. The security is very weak and the stronger than the Caesar. The key value will be the shifting value, that is k is equal to 3 we are going to be using, and in the case of this Playfair I'll be going making use of keyword matrix. We come to the conclusion. In this lecture we discussed how the substitution ciphers replaces the plain text, symbols with the other symbols, and the session has been explained how the Caesar cipher shifts the letters using fixed key values. We also learned that Playfair cipher encrypts the pairs of letters using the key matrix, and finally we understood these classical techniques form the foundation of modern cryptography. So with this we are going to be ending today's session. Thank you.